we want to look at the shape of our distributions now and compare those two shapes. So there are two things that we need to look for. We need to look at what the skew of the data is, if there is one, and the modality, so how many modes are there, how many peaks. So let's start with the skewness. If the distribution's got a long tail on the left hand side, that means it's skewed to the left. And from the diagram there you can see the tail is on the left hand side. This is sometimes also called negative skewness, because if you think about your positive and negative number line, it's on going towards the negative side. If you've got a long tail on the right hand side, we want it skewed to the right, and again we can see the picture there's a longer tail on the right hand side. That can sometimes also be called positive skewness. Modality, we need to look and see, is there one mode, and we use what unimodal is the word to describe that. Uni meaning one, like a unicycle has one wheel, and so that's got one peak. Or if we've got two modes, we call that bimodal. The word bi, like bicycle, means two, so there's two peaks. If we had more than that, and it's not particularly common, but if we did, we would talk about trimodal for 3, quadmodal for 4, and so on. Pent means, like pentagon means 5, and so on. So we'd use those Greek and Latin derivatives to describe them. But usually we only need unimodal and bimodal. So normal distribution is what we're hoping to see. Hopefully that we've got this lovely curve that we see on the graph there, which has unimodal, it's got one peak in the centre, it's symmetric. From the middle, the left hand side and the right hand side are mirror images of each other, and there's a bell-shaped curve. Okay, so it's high in the centre, low at the tails. So that's what we're hoping to see, is a normally distributed set of data. And from all the data that we see worldwide, I would say 80 to 90% of all that data fits the normal distribution. Then let's take a look at our actual rugby players example. So I'm going to start with the backs, and I'm just going to use a pen and draw briefly over the top of that data set. So there's the blue line that I've added. Now that's one peak in the middle, so I'm saying that that is unimodal. Okay, so I can see there I've drawn this blue line in the middle. There's my one peak in the centre, and that's about where my median is from my box and whisker graph. Now, so I've looked at this modality, and I also need to look at the skewness now. So from that median in the middle, I need to look at the distance from the middle to the top and the distance from the middle to the bottom. And I want to compare those distances to see if they're about the same, or if one is a lot bigger or a lot smaller than the other. Now I can also do this on my box and whisker graph by looking at from the median in the middle, what's the distance from the median up to the maximum point, and the median down to the minimum. So I'm looking and comparing those two distances, and it's reasonably symmetric. It's not perfect, but it's reasonably symmetric. So I can say unimodal, it's symmetric, that tells me it's approximately a normal distribution. Now I need to look at my forwards, and I'm going to draw the line over the graph there. And what I see now is I've actually got two peaks, and you can see the lines where I've drawn those in. So this is bimodal, I've got two peaks. If I look at that right hand side, and you can see where I've gone over the graph there in red. So when I look at this right hand side there and compare that side there seems to be a much longer tail on that right hand side. And if I compare that on the box and whisker graph, going from where the median in the middle is and looking at the distance above that and the distance below that, you'll notice that this right hand arrow is much longer than that left hand arrow. So that confirms that this is right skewed data. So we've got a distribution shape that is bimodal and right skewed. So in terms of achieved, what do we need to write? Well, we're going to say for our skewness that the forwards weights, the distribution shape of those forwards weights, and notice I'm talking about the actual variable here, and that appears to be skewed to the right, whereas the distribution shape of the back weights seems to be reasonably symmetrical. So I'm comparing the two shapes in terms of the skewness. Then I want to compare the modality. The backs appear to be unimodal, whereas the forwards are bimodal. So again, I'm comparing the shape here. Then overall, we can say for our sample of these rugby players, the distribution shape of the forwards weights tends to be bimodal and right skewed, while the distribution shape of the weights of backs is symmetrical, unimodal and a bell-shaped curved, so approximately a normal distribution. So there is my achieved answer. I've talked about the skewness, the modality, and overall a comparison of the shape. For merit, I need some evidence from the data. So I'm going to start with my forwards, and I'm talking about the forwards being right skewed, first of all, because the weights above the median are much more spread out than the weights below the median. Okay, so if I just go back to our graph, it was when I was looking at drawing these two arrows here, the weights above the median and the weights below the median. Okay, those are the two bits that I'm looking at there. There's a lot more spread out of that data above the median and a lot less spread below the median. So that's what I want to be able to say there. And then I'm being more specific and giving some numbers. There are a lot of player weights between 100 and 120 kilograms, and then only a few players between 120 and 140, which shows that long tail on the right hand side. For the backs, I want to be able to justify it. It's reasonably symmetric, and it's got one peak that's around about 95 kilograms. And the weights above and below that median have similar spreads. Okay. For excellence, we want to be able to tell the story. Now with shape, that's not always easy to know and figure out what the story is behind it, so don't stress if you can't tell the story there. If you can tell the story comparing the spreads and the centres from before, then that is usually enough.